Hello, Algebra 2 students. Today we're going to look at, I think, a new topic. I may or may not be wrong about that. We're going to look at two things. Compound inequalities. That means inequalities when we think about more than one inequality at the same time. But don't get worried. If you can do inequalities one at a time, you're going to be able to do these. They're not really any harder in my opinion. Hopefully you agree. We're also going to look at absolute value equations, and maybe just before the end of today's lessons we'll touch an absolute value inequality. Just a couple basic ones, and we'll take it a little farther tomorrow. So when I say inequality, of course, I'm talking about something that can be graphed as an interval of space. So most of these problems, I'm going to want you to use interval notation to present your answers. Does that make sense? Because you're going to get like a chunk. Like this chunk of space out to infinity maybe, or maybe just in the middle, a little chunk. You can have chunks of space. That's what inequalities give you as answers. Most of the time anyway. It's possible to have other things crop up, but we won't see those today, right? So you can see in number one, I pretty much have two separate inequalities. So when you're solving a compound inequality like that, just solve each one separately. And I think these are both like easy one or two steppers, aren't they? So what should I do in number one first? Divide by 10, yeah? It's that easy. So I'll show my work today. It's mostly so we're clear. So we have x is less than -2. Done. That little piece is done. So now I'm going to go solve the other piece, not worrying about the or thing yet. Okay. So what should I do first here, of course? Minus 5, yeah. 4a. 21. I tried to make these ones come out nice, just so we wouldn't have to think too hard today. We'll do some more realistic, messier ones tomorrow. Okay? So that one is x is greater than or equal to 7. Now, you guys could graph both of these. I didn't give you the directions, right? The directions say solve and graph. Do you guys think we're graphing in 1 or 2 dimensions today? Look at the variety of problems on the board and tell me, do you think 1 or 2 dimensions is appropriate? Well, do these variables, how many variables do you have in every single problem up on the board? 1. So I'm guessing they're one variable problems, one-dimensional problems, just on the number line. It's possible to graph some of these in 2 dimensions, but we need more skills than we currently have to do that, I think. So another time, soon. So I need to graph this. So let me get my number line going in here. I'm going to graph x is less than -2, so 0, 1, 2. Open circle, of course, right? Less than. And 7. It's going to be way up here. Closed circle, of course. And up. So now, finally, let's talk about the compoundness. What is the symbol that unites these two inequalities? Well, the word is or. I think that sometimes you'll see that as a symbol. Does anybody know the symbol? A couple of us should know it from Algebra 1 if we did Algebra 1 last year. What does or look like? Nobody remembers? Really? This? I've seen this before, yes? Okay. So that means one or the other one. Either or. So that means x is in this that satisfy this one, or x is in this, they're chilling over there, one or the other count. So really there's nothing extra to add to this problem, but or is going to come in on some other ones that we see. Okay? We don't have the interval notation yet, and I didn't really leave myself enough space, so I'm going to put it in right up here. Once you've got the picture, the interval notations be super simple, don't overcomplicate it, read left to right. What's over here? Way down. Negative infinity. All the way up until -2. Parenthesis a bracket, parenthesis, and then we like jump, and we start at 7 up to infinity, parenthesis a bracket on the 7, bracket, and what symbol goes in the middle? Or. Because we want things in this set or things in that set. Any of them work. Okay? Let's look at another problem. So let's have a look at the second one there. Let you guys get that down. I'm going to erase it here because it's getting in the way. Okay, I'm sure you've seen inequalities, or I think you've seen inequalities that are combined like this, where you have like 2 in 1. I'm not really a fan of those, so I'm going to show you a different way to do them today. There's several different ways, but there's reasons. Just hang in there. So it says this thing has to be both greater than -5 and less than -15. So you can see that the compound symbol here is not or, but and. So this is the same thing as writing this. And we need to make that thing accomplish both, being more than -5 and less than 15. Okay? It's a special symbol for and, just like or. Instead of writing and, most of the time you're going to see this. Okay? Now let's set aside the compoundness for a second. Just solve them both separately. You guys can follow along or work on your own. I think it'd be good to pause this and do them yourself. I'm going to keep going today. So 1 plus 1 plus 1, -4 is less than 4x. That says x is greater than -1, right? Plus 1, 16, divide by 4, you get 4. Bam! We can graph both of those. What did I recommend? Do you guys remember the other day? What did I recommend if you have like a backwards one like that? Turn it around so you don't mess it up. So easy to mix this up, right? You got to maintain the side that everything is on. I think that's a lot better choice. All right, let's graph each piece separately. Notice I'm not even worrying about this and thing at all yet. So x is less than 4, so we'll go 1, 2, 3, 4. Closed circle. X is greater than -1. So -1 is right here. It needs a different color. Maybe green. Closed circle, shade above 1. So this time it looks like I've shaded in the entire number line, right? -infinity to infinity. So, is that the answer? -infinity to infinity? That's where you've got to think. Is this or and? If the problem had said or, and it's perfectly feasible that it could have, totally possible, then anything that was blue or green would be a solution, which in this case is everything. So our answer would be -infinity to infinity. But it didn't say or, it said and. So that means you've got to be both blue and green. Don't make it any harder than that. And is another way to say overlap or the intersection of two sets. So where's the overlap in here? I mean, if you use different colors, it's really easy to see, right? So I'd really recommend using different colors on this if you have them. The overlap is just from -1. I think that's blue and green, isn't it? And then all the way up till 4, that's both blue and green. Only that is the overlap, where you're both blue and green. Or you're both less than or equal to -4 and greater than or equal to -1. That's what and means. So the set is very easy to express with interval notation because you just go bracket -1 to 4. And that's the solution. So we've already recognized something, I hope. I erased this one. But it looked like this, didn't it? Basically look like this. Something like this, right? Ands typically, not always, are going to be a little chunk somewhere. Not always, but a lot of the time, okay? Ors, and this is going to help you a lot if you remember it. Ors typically, not always, there'll be exceptions in your problems even, but not very many. Ors typically are going to be two separate pieces going to infinity, typically. So that's a good, nice mental check on yourself. I'll be using that mental check on some problems, maybe even today. We'll see how far we get. All right, so there's a couple inequalities. We'll do at least one more tomorrow as a warm-up. Might have some candy to offer the first person who can do it correct. So, these aren't inequalities at all, right? So I'm going to warm you up with an absolute value. What are these? Not inequalities, they are equations. So let's warm up with a couple absolute value equations, and then we'll do an inequality and call it a day. All right, so I'm going to be doing these graphically with a picture so you get the idea, and then I'm going to teach you a little shortcut. You can do them whichever way you'd like. If you want to be really good at this stuff, I know both. Up to you. All right, so can you guys remind me, what does absolute value mean? It means like 7 different things, but I think you guys probably know like 1 or 2. Already know what absolute value does to things. What's it mean?
It means that whatever the number is, that's how far into it.
Perfect, Marisa. I love it. That's a really good one that you should know. If you heard Miss Reynolds, she said how absolute value is how far away something is from 0. That's really good. Does anybody have a simpler way to think about absolute value? I think you all do. What's it do to negative stuff? Turns it positive. There's a lot of other ways to think about absolute value as well. I think we're going to use Miss Reynolds' one today. It's distance from 0. That's what absolute value is. I'd write that in your notes. Absolute value, one way to think about it is distance from 0. Okay? That's all we need for today, because we're thinking about one-dimensional number lines, so distance from 0, I think, is going to come. So let's solve this one with a picture, theoretically, if you will. We're solving for what? X. We want to find the x's that satisfy the equation. What this says, using that idea, is the distance between what we want, x, and 6 is 2. Negative is how far apart one thing is from another thing. Isn't that what subtraction really is? When you subtract 8 minus 3, 8's over here, 3's like right here, my face is at 0, and 8 minus 3 is 5. That's the distance, or the distance apart that they are, right? So we're just using that idea today. So this says, I'm going to ask you guys to repeat it tomorrow, if not today. The distance between x and 6 is 2. That's how you say that. You might even write it in your notes. The distance between x, what we want, and 6 is 2. So if you know that well, then you can just like draw it. You can be like, okay, the distance between x and 6, okay, so 1, 2, 3, 4, 5, 6. How far away do I need to go from 6? 2. So you go like, and you can clearly see that one of your x's is 4, and the other one is 8. There's the answer to this problem. x1 is 4, x2 is 8. There's 2 solutions here, so you have 2 solutions to something like this. Now, a quick way to do that, if you don't want to use the distance idea, yes, Zach?
How would you write that answer?
X equals 4, x equals 8? Yeah. Good question. I'll write it down another way here. So you can do that a quick way, a quick algorithm to do that is to just say x minus 6 equals 2. I just totally dropped the bars. Do that problem. What do you do to both sides? Add 6. What do you get? 8. And then do a whole separate problem. Use bullet points. And say x minus 6 equals. And remember that distance along a one-dimensional space can be this way. It can also be that way. This way is positive, that way is negative. Okay? So add 6 to both sides there and you get 4. So would you guys like me to do this one with a picture, or we're just using our algorithm? See that you really care. Well, if you use the algorithm, it's super simple, right? You guys are a hard audience. Good? Mr. Beeford?
I thought you had to make this 64 now.
Yeah, that's what's supposed to be negative. This is not supposed to be touched. You got it. Solve both problems, and you're done. That's it. That's how easy these are. 4x equals what? 64 minus 8 is 56. I think 4 goes into 56. You might need your calculator. But of course you guys have those on your desk and are ready to do it, right? Oh, I guess we'll have to try it some other way then. I think that's 14. You guys better check me.
14.
Yeah.
Don't trust me, I'm bad at that kind of stuff. Okay, so then subtract 8 there. think x goes into that to 44 goes into 72, 18.
Yes.
Done. Before we see our last inequality problem, I want to do this one with the picture as well. This one's a little more challenging to do with the picture. It requires you to actually know Algebra 1. So let's see if you guys do. This one with the picture. There's no minus. Oh man. So I need to make there be one. How can you change a plus into a minus and not change anything really? Well, you don't want to do something on both sides. There's inside weird stuff here. We're getting into strange, dangerous waters. So I want this to be 4x and 8. But I don't want that to be a plus. I want that to be a minus. This is quite important strategy we'll use. Glenna? Yeah. Love it. Nice. Minus negative 8 is the same thing, isn't it? So that says the distance between 4x and negative 8 is 64. So we could try to draw that. I think we still have a problem though. 4x isn't just x, so we'd have to be drawing with scales. That would kind of get complicated. So I think a better strategy to begin with is to do this. Say that this problem is exactly equivalent to factor inside. You can't see what's happening to x when 4 is attached to it, and oh man, that is important this year. We're going to see that again and again and again and again in all kinds of different situations. X isn't by itself, you're not seeing what's truly going on. It's going to fool you. So how do you get x by itself? You go like this. I'll give you guys a hint since it's early. What am I doing? I'm reverse distributing. What do we call reverse distributing? What do you call pulling out what they share? It's one form of factoring, right? So I'm factoring out 4 and seeing what's left. X is left and 2 is left. Now, since this is a product, you can split this absolute value up and pull that 2 out. If it was negative 4, when you pulled it out, it would become positive 4, right? And now I can get rid of that 4 to the other side. We're going to do another one like this tomorrow. But you're going to have x plus 2. And if you know your power tables well, hopefully you're recognizing, because 64 over 4 might be hard for you, unless you know your power tables well, like we're going to take a quiz on in a minute. 64 is something from our power tables. What is it? This is why we're doing them. Little things like this, but they're going to get more and more common. It's 4 to what power? Okay, so if you're not seeing that yet, you guys are not ready for power table stuff yet. You need to work harder on it. 64 is 4 cubed. So what's 4 cubed divided by 4? It's 4 squared. What's 4 squared? 16. We're going to be seeing stuff like that all over the place this year. So if that was hard for you just now, that means you have not prepared for power tables. You're going to have trouble. You'll shoot yourself in the foot. It's going to get harder. So, you. Anyway, now we can totally see this. We're going to apply Colenna's strategy and go minus and minus. Draw it. This says the distance between x and negative 2 is 16. Here's negative 2. If I go 16 this way, where am I going to get to? Boom. If I go 16 this way, where am I going to get to? I think we've seen those before. So clearly, that was a lot more work than just applying the little algorithm here, right? But that's the level we want to get to in Algebra 2, is being able to follow stuff like that. Not just to understand how to apply an algorithm, but be able to construct our own reasoning. Okay? Last thing I'm going to do with you guys today is an inequality. I think we'll just do one. We'll leave the other one for tomorrow. Should give you plenty, so you can do almost your entire assignment if you wanted to. So let's say we've got x minus 6 is less than or equal to, I don't know, let's make it pretty easy, just go 2. Let's see. Who can read that to me? somebody read that to me? Katie?
Between X and 6.
You can try too, Robert, if she's not right. Nice.
The distance between x and 6 is less than or equal to 2.
Wonderful. So the distance, she said, between x and 6 is less than 2. Can we draw that? Yeah, that'd be pretty easy to draw. We don't have to do any fancy factoring or anything like that other problem. This is just basic ingredients. So I'm going to go the distance between x and what? Distance between x and 6. So I should go like up to 6. 1, 2, 3, 4, 5, 6. The distance between that and what we want, x, is 2 or less. So this time we'll go like 2 each way. I kind of made like the same problem as a second ago, right? Go 2 each way, except we don't just want the edges. Those work, right, because of the equals. Where are the other things that work? These. Inside. So that's the answer. 4, 2, 8. That entire interval between 4 and 8. Now you can of course do these with an algorithm, and I'd recommend that you do the easier ones with a picture and the ones that get a little bit tough with an algorithm. But you can do them all with an algorithm if you want. Here's the algorithm. It's just like the other one. X minus 6 less than negative, or less than 2. I just dropped them. Add 6 to both sides. What do you get? 8. Then x minus 6. Wouldn't it be nice if it worked just like the other one? I think it does. So what should I put over there? Negative 2. But this is an inequality now. It's not just one finite point. It's a whole chunk of points. So instead of just being like, go that way, when I go that way in inequality line and I change directions, what do you have to do? You have to flip the inequality. So change. That's how I remember the algorithm. Change. And if you solve that one, you'll get plus 6 is 4. Let's graph those separately and see if it looks the same as our picture. So we've got 0, 1, 2, 3, 4, 6, 7, 8. Greater than 4. Less than 8. Is it negative infinity to infinity? Go with your gut. We know the answer from the picture is 4 to 8. So what symbol must we have had to put in here? Or and? And. That's something you've got to remember. It should make sense, but you've got to remember it. That's why knowing this, all this stuff, including the graphical explanation, is important. Okay? So and goes in the middle there. This is what I like to call, what do you guys think? An inside or an outside interval? Go to a place, find the edges, outside, inside. This is an inside interval. As soon as I look at one of these problems, I immediately know it's a chunk of space on the inside because it says less than. It says go out, less than. If it said greater than, you're going to get 2 pieces like this, which would be and or. Okay? That's basically the whole lesson. We'll do a couple harder problems tomorrow, but that's it. See you next time.